All right, so we're going to start with linked list traversal. So again, as a reminder, we're using this node struct, and we are going to be building a linked list that's singly linked, and the last node is going to point to a null pointer. So I'm going to first show you how to write this in just a function. So this is not within a class, but this is something that you can write in any main. So assuming that you have access to the node struct, you write a function that takes in a node and just prints out whatever that node is linked to using that node struct pattern. So this is what you should have probably seen before. So the idea of this first one is it's a recursive implementation of traversal, and it's just going to print out the list. So let's say that we pass in this to the function. So we could do that by, setting up in main. So let's say this is main. So in main we have a node pointer, and then let's say that we fill the list, which we're going to do in the next video. So let's just assume that we already have a way to fill the list. And then to call this function, we're just going to call print1 of list. So there's no class or anything. We're just running this function inside of main. So list points to the front of some list. Let's just assume the strings 1, 2, 3 are in the list. And let's just walk through what a recursive traversal does. So there's a base case that's going to stop once the node pointer list equals null. So since it doesn't equal null, it's going to print out the value pointed to by list. So out in our console, we're going to get a 1 printed. Then it's going to recursively call itself, and it's going to send in the next item in the list. So now coming in to the recursive call, as we go back in, list is now going to point to the second node, and since it's not null, it's going to go ahead and print it out, and then it's going to send it in again into the recursive call to the function. So now our list is going to be pointing to the third element, the third node in the list, and then again, that is not null, so it prints it out, prints out the value, and then it calls it again a third time, and so now list is going to be pointing to null. And now this is true finally, and so it returns, and it returns out of the recursive calls, and it ends the program, and so it's printed it all out. Linked structures are very typically written recursively because they're very innately recursive, and this is a recursive implementation of traversal. However, you have to be really careful when you write recursive functions on really large inputs like linked lists, because as we saw, I think last week or the week before, when you look at memory of function stacks, every time you recurse, a new piece of the stack is created. So recursion is really inefficient if it's being called on really long lists, and it can lead to stack overflows. I wanted to show the recursive implementation of some of these functions because they come in handy when we start looking at other link structures like trees or graphs, and so it's good to start thinking recursively, but you're going to not want to write some of these recursively on really long linked lists because you will reach the stack limit and overflow the stack on really large inputs. So an iterative traversal looks like this. Again, same main call. There's no difference other than you would call print2 instead of print1. And here we have list pointing to the front of some list. So what's going to happen here is as long as the list is not null, it's going to print out its value, and then it's going to advance to the next item in the list. And then it's going to print out its value, and it's going to advance to the next item in the list, print out its value, advance to the next item in the list, and then once list equals null, the loop ends and you get everything printed. This is the general flow for traversing through a linked list, and that's generally how you can do it. So this iterative method is the one that you're going to want to use on the problems that we're going to be working on, because we're going to be working on very, very long lists, and we're not going to want to have the excessive stack kind of created in memory through the recursive call. Recursion can be used efficiently on some things because you pass stuff in by reference and stuff like that, but the stack frame is still created on each function call. So if something is being created in that stack frame, it's going to potentially lead to stack overflows on large inputs. So that was how to do it just in main, assuming you had a link structure and you just wanted to print it out. So what does it look like in a class? So here is the private portion of our class that shows all the private member variables that I showed you before. And then this is where you would place some sort of traversal code to print out. This is one of the first things you want to write in implementing a class, so that you can see right away if what you're implementing is right, because you can print it out. So I always recommend it being the first thing that you write. A couple of differences you'll notice is that you don't have an input because you have a private member variable called front, which keeps track of the front of the list, and so you don't need to send it in, and you can't send it in because the struct is private, and so outside of the member class you can't use it. So instead you're just going to set up a temporary node pointer that points to the front, and then you'll move that node pointer around to traverse through the list. You want to do this because if you directly move the front, then by the end of your print call, your front will now point to a null pointer, right? So you want to make a copy of the front and then move the pointer that you've made a copy of instead of moving the front pointer itself. And so that is how you can traverse and print out a linked list structure inside of a class. So it's just a subtle difference, but a lot of people, when they start moving into class implementations, they kind of get lost of like what the object is or where they are, you know, because you're kind of floating around in like a different world when you're working in a class. So in this particular implementation, we haven't written like the constructor or anything, so I don't really have, that's why I didn't show all the mains. In all the rest of the videos, I'm going to actually show you how to call it in main. But just to give a little preview of what that will look like in main, you'll basically just create a linked list object. So you can imagine that you have maybe a default constructor that we'll call to create the list, and then to print it, you'll just call the print function. So that is how you write a print function inside of linked list class, and how you traverse a linked list that is a private member variable of a linked list object. All right, that's it.